Hello, good morning, good afternoon, everyone.
Good afternoon, madam.
Uh, Please, I can see 4 or 5 uh, participants. Is that the total number enrolled, or are we expecting more students to join?
And I will join soon.
Oh, okay, fine. So let's wait for about 10 minutes.
Yes, please.
Oh, okay. Okay. Uh, so it's 1:10. So I think we should start now. Okay. So my name is Ananya Santhosh, and I'll be handling advanced Java technologies with you this semester. Can everyone hear me clearly?
Yes, madam.
Okay.
Yes,
So
madam.
thank you. So before we begin, let me give a brief introduction about advanced Java. Okay, so it is important that you already have a good understanding of basic Java concepts such as variables, operators, control statements, loops, methods, classes, and objects. So if you have forgotten some of these topics, please take some time to revise them, as we will be building on that knowledge throughout this semester. Okay. And please note that all course materials, slides, announcement, and assignments will be uploaded to the LMS. So make it a habit to check the LMS regularly throughout the semester. So, all right. So we will start with the course outline and discuss what we'll be covering over the next 10 weeks. I hope you can see the slides.
Yes, yes, madam.
Yeah.
Okay. So this course builds on Java knowledge you already have. Okay, so let me. So we will learn advanced object-oriented programming concepts, error handling, file processing, and database programming. Okay. So by end of this course, you should be able to design and develop Java applications, use inheritance, interfaces, and polymorphism, handle exceptions effectively, and read and write files, and connect Java applications to MySQL database using JDBC. Okay. So your final grade consists of 40% continuous assessment and 60% for the final exam. So the continuous assessment include quizzes, assignments, and mid-semester test. And the final exam will include multiple choice questions, short answer questions, and programming questions. Okay. So this is a plan. So we will start with the classes and objects. Then we have methods, constructors, and this keyword. And in week 3, we will be starting with inheritance and access controls. Then we'll continue with polymorphism and extract classes. Then packages and interfaces, exception handling, Java I/O, serialization and advanced I/O. Then the last unit will be JDBC, that is database connectivity. Okay. So this is a detailed topic-wise list. So you can go through it. I have already uploaded on the LMS. Okay. So you will complete 3 practical assignments during the semester. So first assignment will be based on the basics, that is classes, interface, inheritance, and interfaces. And the second assignment will be a file-based application using Java I/O. And the third assignment will be a database application. Okay, so these assignments will help you apply the concept learned in class. Okay. So, and you will have a mid-semester test. So that will have multi-choice questions, short answer, program, or long answer questions. Okay. And these are the tools. So when you studied Java in your last year, second year, which platform or ID did you use? Was it Eclipse or VS Code or NetBeans or something else? Anyone?
Please, can you come again?
Madam,
Oh, okay. So when you studied Java in your second year, you are level 300 students, right? So you already have a basic knowledge of Java. So which platform or IDE did you use?
We've not done Java.
You have not done, but you are level 300.
yes,
Yeah, we are top up students.
So this is the first time you are learning Java.
yes,
Oh, okay. So no idea about practicals, Java programming. And what about C++? Have you done C++?
Yes,
No.
the
we-
basics.
Oh, okay. But this is advanced Java, so I have prepared um a little bit advanced. So you should have these all things covered in your Java. So I think, okay, fine. So I'll start with the classes and objects. So let's see how we can manage. And you will get tutorials online. So you have to go through that basics Java topics. Means you have done C++, so you know what are variables, loops, arrays, right? Basic of object-oriented programming.
yeah, yeah, most of those.
Yes. So Java is also an object-oriented. So whatever you have learned in C++, we will use it here, but only the difference is maybe the um, structure, syntax, but almost C++ and Java are same. Okay, so don't worry. Let's see how we can, how I can make it simple so that everyone understand. I was thinking you
Okay.
have done Java in your second year.
No.
Okay, so you have completed diploma.
Yes, we are top up students.
Yeah, we've completed diploma and
Okay, okay, I understand. And I'll share you more tutorials on the LMS. Okay, so you have to practice more.
okay.
Okay,
Okay.
so this is a course policies and expectation. Okay, so there will be 6 units, and we also have to do the practical sessions. Okay, so one important thing I would like to mention is that this is a programming course. So programming cannot be learned just by attending lectures or watching videos. So it is very similar to mathematics. Okay, so if you only watch someone solve maths problems, you won't become good at maths. So you need to solve problems yourself and practice regularly. The same applies to programming. The more you write code, the more you'll understand the concept. So if you only listen during the class and do not practice afterwards, you may find the topics difficult. So my advice is simple: practice, practice, and practice. Try every example we discuss in class. Experiment with the code and make mistakes, fix them, and learn from them. The more you practice, the more confident you will become in programming. Okay,
Okay.
so let's start with the first unit. So I'm just closing this window. Okay, so let me open the unit 1. Okay, So can you see the slides?
Yes,
Yes,
please.
please.
Okay. So today we begin Unit 1, Classes and Object, which is one of the most important topics in Java. In fact, everything we do in Java is built around classes and objects. So many of you may have written programs where all the code was placed inside the main method. So while that works for smaller programs, but it becomes difficult to manage as programs grow larger. So in this unit, we will learn a better way of designing programs using object-oriented programming. So object-oriented programming helps us organize our code, make it easier to understand, and reuse it in different applications. So before we continue, let me ask you a question. How many of you have written a program where everything was inside the main method? I'm talking about C++. Okay, don't worry, I'm not going to ask any Java things. You can take the C++ examples, or have you written programs on C? Have you done practicals on C++? What happens?
Yes. Yeah.
Okay.
So one thing too is most of us the time period between when we got our diploma and now is quite significant, and most of the practical aspects we unfortunately uh, have not been able to retain most of them, right? So we are hoping that moving forward we can catch up, So yeah.
Okay. So can you access the LMS?
Yeah, we can, but I can't see the Java course on the LMS. I don't know if it's the same for everybody.
Yeah, I have already uploaded everything, every detail.
Um,
I mean, what you have to revise and everything I have mentioned in the LMS. Uh,
okay. Currently I'm seeing only 4 courses for this semester. I think the other ones are still being pushed to us or something. I don't know, but I'm only seeing 4 at the moment, and Java is not part of that.
okay. Okay, I understand. I'll do one thing. I'll share everything on WhatsApp.
Okay, thank you.
Okay, so okay, so this is our first lecture, but I have a request to revise some basics of programming. If you are okay with C++, just revise the basics. I mean, how to declare a variable, or what are variables, what are operators. So
Okay,
how to write a program, simple program. I'm not talking
okay,
about the advanced C++ part, just basics.
okay,
So because this classes and object is the advanced level. So if you
okay.
are not revising anything and coming and attending the class, then it is very difficult.
Yeah, that's true.
Yes. So whatever the notes I'll share, if you want C++ basics, I'll share it with you. And again, I'll share the Java basics. So you have to
Okay.
find out the time and then at least half an hour, at least you have to try it.
Okay.
Or
We'll
I think on Sunday, only you have two classes, right? This is
yeah.
my, okay.
Yeah.
So at least morning time you will get it. So you have to practice it.
Yes. Yes. Yes, madam.
Okay. Okay. So let's start with the X. So this is our plan. So we will start with the basics of classes and objects. Then we'll learn about methods and constructors. And then we'll explore the this keyword, object passing, and method overloading. And we will also learn how Java automatically manages memory through garbage collection. And finally, we will complete some practical exercises to apply what we have learned. So by end of this unit, you should be comfortable creating classes and objects and understanding how they work in Java. Okay. So now let's begin with our first session, fundamentals of classes and objects. So before we start writing the Java code, we need to understand some important concept. So we will answer three basic questions. That is, what is object-oriented programming? What is a class? And what is an object? And how do we use them? So once you understand these concepts, the rest of Java will become much easier to learn. Okay, so let's start with object-oriented programming and see why Java is called an object-oriented programming language. Yes. So has anyone heard the terms class or objects before? What do you think they mean? Any idea? Okay. Okay, so no problem. So let's start with object-oriented programming. So in traditional programming, we can take an example of C language. I'm not talking about C++, C language. We focus mainly on functions and steps. In object-oriented programming, we focus on objects and data. So object-oriented programming helps us organize related data and actions into classes. So this makes programs easier to understand and manage. It also allows us to represent real-world entities such as student, car, bank account directly in our programs. So because of this, our code becomes more organized, reusable, and easier to maintain. So remember, Java is built around object-oriented programming concepts. So everything we create in Java is based on classes and objects. So can anyone give me an example of a real-world object that we could represent in a program? Any example?
Yeah. Toyota.
Yes. Toyota. Then student,
Yeah.
employees. So these are the examples of objects. Okay. So now let's see class versus object, the blueprint. Okay, so imagine you want to build a house. Okay, so before building the house, you first create a blueprint or plan. So in Java, the class is like that blueprint. It describes what the object will have, but it's not the actual object. Okay, so the object is a real thing created from that blueprint. So when we create an object, we use a keyword new keyword. In C++ also we are doing the same. We are using the new keyword. So Java allocates memory and creates the actual instance. For example, if we have a class student, okay, so while student 1 and student 2 are objects created from that class. So class means a blueprint or template. And objects are the real instance created from that class. So if a class is called fruits, okay. So what could be some objects created from it?
Mango.
Yes, mango, apple, orange. So these are the objects of that fruit class. Okay, so class is the blueprint and an object is a real instance created from that blueprint using the keyword new. I'll give you one more example. We can take this advanced Java as a class. Okay, so if advanced Java as a class, then you are the students are the objects. So if I take the first student, then that student will have the name, then he will have the index number, he will have the course, address, age, everything. So these are the properties of that student. Okay, and even if I take the second student will also have the same properties, and the third student also will have the same properties. Okay, so class is a collection of objects that share the common properties. But if we take a class, then lecturers are not the objects because they are separate. They share different properties. I mean, they are different. They don't have the index number. They don't have the course, right? They will have some different number. Some employee ID, the lecturer ID, then department, then designation. So these are the lecturers' properties. So you cannot combine student and lecturers into one class because they will have different properties. So class is a collection of objects that share common properties. So if I take a class car, so the objects will be Toyota, Honda. So these are the objects and they will have the same properties. Are you getting class and object? Are you understanding?
Yes.
Yes, madam.
See, these are the basic things. So if you are not understanding, you can tell me. I'm ready to repeat it again. But understand the concept. Okay, so now that we understand what classes and objects are, so let's see how a class is written in Java. So every class starts with a keyword class followed by the class name. And inside the class means, see here you can see an opening bracket. Okay. And I'm closing the class at the down. So this is the body of the class. So in between whatever you are writing, that is the body of the class. So inside the class, we usually have two main parts. The first is the instance variable. Instance variables. So these stores the data or information about that object. And the second one is the methods. So these define the actions or behavior of that object. Okay, so think of it this way. Variables tells us what the object has, and methods tells us what the object does. Okay, for example, let's take the student class. So a student class may have variables such as name, age, and course. So it may also have methods such as display info, means display student details, or calculate grade. So when creating a class, we normally place the data at the top. Data means the instance variables. And the methods below it. Okay, so if we create a car class, the class name is car. Okay, so what variables might it have and what methods might it perform? Yes, anyone? See, we are creating a we are creating a class called car. Okay, so tell me the variables and the methods of that car class.
So we may have a variable like model.
Yes. Then we can have color. Then we can have cost, then speed, whatever the properties are. So that is the variables. And what will be the methods? Yes, so what functions? What are the functions of a car? Start, stop, accelerate.
Fuel.
Yes. So these are the methods. So a class contains data and behavior, that is method. Okay, so data are the variables and behavior are the methods. So together they describe an object. Yes, are you getting?
Yes, madam.
Okay. So now let's see the example. So let's see how a real class looks in Java. So here we have a class called student. Okay. And inside the class, we have 3 variables. So the rule number 1 was we should first declare the variables and then methods. So first I'm declaring the variables. So I have string. Sorry. So first we have string name. So I'm going to store the student's name. So student name is a group of character. So what data type we are going to use? It is string. It's a collection of characters. And then we have course. Again, I'm declaring it as string because it is BIT or BSCIT. So the course name is also a collection of characters. And then we have age. So age is an integer that stores the student's age. So these variables represent the data of the student object. So here I'm just taking only 3 properties. If you want, you can declare the student index number, then the marks, the percentage, address, phone number. So that properties you can declare it here. Okay. So after this, you can, if you want to add the phone number or the index number, you can add it. And after that, we also have a method called display info. See, this is how we write a method. I'll explain you what is methods. We have a session on methods, but just understand the syntax of a method. Okay, so here, this display info, that is a method name. I'm trying to print the student details, the student information. So I'll print the name, course, and age. So how to print the output on the screen? You will be in C++, you will use cout, right? So in Java, we are using system.out.println. And then The first line is I want to print a heading that is student information. So I'm writing it in the double quotes because it's a string and I want to print as it is. So I will write it in the double quotes, and in the next line, I'm printing the name and then course and the age. So these are the variables. I mean, how we display the output in C++. The same way, but only the syntax is different. In C++, we use C out, then we use less than, and then we write it in double quotes. The concept is same. See, only the syntax is different. We are using system.out.println, and in bracket, you have to write your output. So I'm printing the name, course, and age. So display info, I have started here. See, you can see an opening bracket, and whatever the display code I have given here, it is inside this display info because I'm closing that method here. So this block is the body of display info. I'm closing it here, and after closing the class, I have to close the, after closing the method, I have to close the class. So this method simply displays the student's details on the screen. Okay, so this class contains both data and behavior, means variables and methods. So which is the basic structure of most Java classes? Okay. So now a question. If we run this class, will it display anything on the screen? So you remember C++? You remember the method main, function main. You write int main, and then we write the actual code inside the main. Yes, main method. Main method in C++. What is that main method? What happens if there is no main method in C++? Any idea? Okay, so if I run this class, it's not going to display anything because we have only created the blueprint. We have not created any student object yet. So to use the class, we must first create an object from it. So a class defines what an object should look like. But nothing happens until we create an actual object from that class. Okay, see, we have already explained class is a blueprint. So here, this whatever the variables and whatever the methods we are defining it, it's inside the class. So we are just It's just a blueprint or a template. Like if you want to build a house and you are saying you have done with the blueprint, you have the plan, but you cannot stay, right? You have to build the house. So the same way, this is just a template. So to use this, you need to create the object. So now let's see how to create an object. So in Java does this object creation in 2 steps. The first step is student1. Student is the class name. See, in the previous example, let me go back. See, this is a class. So we are going to create the object of this class. So you are giving the class name, that is student, and the object name. So I'm giving it as student1. Okay. So here, this line. So you can see no memory allocated yet, just a reference. So here, student1 is only a reference variable. No object has been created yet, and no memory is allocated for storing student data. Okay, so what is reference variable? What is reference variable? Reference. Okay, so a reference variable is a variable that stores the address of an object, not the actual object. For example, you think of an object as a house. Okay, and the reference is like the house address. So instead of holding the entire house, okay, the address tells the Java where the house is located. So this is just an address, not the real house. So now go to the second step. So after writing this line, we are writing student1 equal to new student. The keyword here, we are using the keyword new. So the keyword new creates the actual object in memory. At this point, the student object is created and ready to use. So in practice, we usually combine both steps into a single line. So student1 equal to new student. Again, this is a student class. So this is the most common way of creating objects in Java. Are you getting? Hello?
Hello, madam.
Yeah, are you understanding?
Small.
Okay, so just understand classes and objects. Okay, so I'll share you the basics of Java and everything. the course materials and everything. I'll share it with you. I know this is your first lecture and you don't have any Java background, but just understand what is a class and what is an object and how to create it.
Okay.
Okay, so I'll explain it again. So this is a class student. So if you are writing a class, if you're writing a program, then you will start with the class. Class, you will write the class name. So in this example, I'm using student. Or if you are, if you want to use employee, and where you will be storing the employee details. So you can create a class employee, or you can create a class college. Okay. And you can create a class bank. Okay, so here class and then class name, that is student. And then you open the brackets. And after writing the class name, you are entering into the class body of the class. So the first step is you have to define the variables. Means what are the properties of that class? So if I take a student, then student will have, the object will have the properties ID, name, index, then course, percentage. So that properties I have to declare it first. And after declaring all the properties, the second step is you have to define the method. Suppose you are creating an application where you will be entering the student details. So you are the admin and you are entering the student name, index number, and the scores of individual subject, marks of individual subject. Okay. And the program will calculate the total marks and the percentage. So you have defined all the variables. And the next step is you have to define the methods. So your program must calculate the total marks and the percentage to find the grade of the student, right? So you can create a method, calculate percentage or calculate grade. So you will write void. Void, it's a data type. In C++ also, we have the same data type, void. Yes. So can anyone tell me what is void data type?
Um,
Okay.
This is it void as an empty?
Yes. It's an
No.
empty data type.
Okay.
Okay, so in this example, I'm not calculating anything. I'm not returning anything. I'm just printing the student details, name, course, and age. So this method is just for the display purpose, not for any calculation. So if your method is not returning anything, returning any, for example, if you are calculating the percentage, and that method is going to return an output, that is percentage. Your method is calculating the percentage. Okay, so the method will return the percentage. But in this example, I'm not calculating. There is no calculation, just printing the name, course, and age. So in that case, you can make your method as void. Void means empty. It does not return anything. Okay, so if you wanted to return percentage, then you will declare your method as float. Float, calculate percentage. So calculate percentage will be the name of your method. And float means it will return a float value, a decimal value. Okay, so it depends on the method. If you're performing any calculation and you are returning anything, then you should use the same type. If you're returning an integer, then you should declare your method return type as integer. If you are returning a string, then you should write the return type as string. If you are returning a character, then you have to write the same return type for that method. So the void means that is a return type, return data type. So this method is not returning, so I'm using void, then the method name, and you are writing the body of that method. So after writing this method, don't forget to close it. And then after defining all the methods, now in this example, I'm defining only one method. But when you are developing an application, then you will have n number of methods. Okay, so and after everything, you have to define it in the class and then close the class. And the next step is, after defining the class, next step is to create the object. So how to create the object? Class name, then object name equal to new class name. Are you getting?
Yes, madam.
Okay. Okay. So here, student1 creates only a reference variable. And new student creates the actual object in memory. Okay. So now we have defined the class. Now we know how to create the object. Yes, so now let's put everything together into one complete program. So let's start from this. So this is where we stopped. We defined the student class. Okay, this is where we stopped. And after this, come to this slide where you will be creating the objects. So you will have, you must have a main method. Yes. So inside the main method, we first create a student object. So in C++ also we have main method, main function. We write as int main. Yes, so same way Java also has a main method. We call it as public static void main. And in bracket, you are giving the arguments. I'll explain you in detail. We have a session on this static and methods. So I'll explain you what does this mean. Okay. So just understand the syntax. So we write public static void main. Okay. And after this, See, we are opening the bracket. So inside the main, we are creating the object. So I'm writing student1 equal to new student. So this means we are now creating a real object in memory. So after that, we use dot operator to access the object. So think of the dot operator as a way to open the object and access all its inside parts. So my object name is student1 dot. Then I can access the variables. I can access the name, I can access the program, then I can access, then what else? Okay, so here I used course. Sorry, I made a mistake here. I'm using program. So sorry, this is course. So student1 dot course, and the method is student1 dot display info. And you can also add student1 dot age equal to 23. So the first, this student1 dot name equal to Mensa. So this assigns a value to the name field inside the object. And same for student1 dot course, BSc IT. And then we call the method student1 dot display info. So this tells the object to perform an action and print the details. So when the program runs, it displays the student information on the screen. Yes, are you understanding?
Yes, madam.
Okay. So if I create two objects like student1 and student2, so will they share the same data or have separate data? My question is, I'm creating two objects. So one I have already created it, that is student1. And again, I'm writing the same object creation. So student2 equal to new student. So right now I have two objects, student1 and student2. Yes. So will they share the same data or have separate data?
They will share the same data. That was declared earlier.
No.
Uh, are
Separate.
we are we talking about the values or the data that was declared?
Yes, see, I have two objects, one student1 and student2. So student1, I'm giving the name Kwame Mensa, then course BSc IT, and then I'm displaying it. And then I'm creating another student2 where I'm going to have different, each student will have, the properties will be different. Means the name will be different. The second student name is Emmanuel. And the course is BSc Computer Science. Okay, so student1 and student2 are different. They hold different data because each object has its own memory. See, suppose in our class we are 10 students. Okay. And I'm going to store your information. So I'll start from S1 to S10. Okay. So S1, I'll store the name, ID, then program, then marks, everything. And if I go to student 2, will the student 2 also have the same name? Kwame Mensa or Emmanuel or any Alex?
No.
The name?
No.
Yes. So we are going to store the data of students. So in general, they are students. But if we separate them, they will have different name, different index number. Okay. So each object has its own memory. So the class defines structure and the object stores real data. Okay, and the dot operator is used to access both variables and methods inside the object. Okay, so when you were doing C++, you might have used, everything you were writing it inside the main. So if you want to print a student name, you will write C out, then you will write this variable name S name. If you want to print the index number, then again you will write another C out and you print the index name. But here we are not writing everything inside the main method. We are writing it in the class. So here I'm declaring it as name, course, and age. But if I want to display it in the main, I cannot directly write system.out.println name because the name is a class variable. So through its object, I can access it. So that's why we are writing object name dot variable name, student1 dot name, then student1 dot course, then student1 dot age. So it is like you have the house, but you need the key to open the doors to access everything, right? That key is the dot operator. Okay. Okay, so now pay attention here. This is a very important concept. Okay, so in this example, I'm writing person P equal to new person. I'm trying to create an object. So P is an object. Okay. And then I'm writing P dot name equal to Kojo. Okay. And P dot program equal to, I'm assigning BSc IT. And then I'm writing person Q equal to P. So what is happening here? We are not creating an object. Instead, we are copying the reference, not the object itself. So it is like copying a house key, not building a new house. Okay. So both P and Q point to the same object in memory. So now what happens next? I'm writing q dot name is, I'm writing another name. And then I'm trying to print p dot display and q dot display. So you will see this name, not the previous name, that is Kojo. Why? Because both references are pointing to the same single object. So when we change the data using Q, it automatically affects P as well. Okay, I'll explain you a simple example. Imagine you are staying in a hostel and you have a roommate. So you are sharing the room with your friend. Okay. So you both will have the keys. But you are accessing the same room. Same way, P and Q are referring the same memory. So memory is a room. So if you change anything in the room, like if you change the paint, so if you are changing the paint.
In class.
Yes. Hello. Any question? Hello. Any question?
No, please, madam, I think it's a mistake.
Oh, okay. So if you change anything in your room, your friend is also staying in the same room. So he can also access it, right? The room is changing it. So same way, if you are changing q dot name to Akaso, so the same name is going to that memory. So P will also have the same name, not the name which P, see, before we were initializing Kuju. But now P will also have the same name. So both P and Q refer to the same object in memory. So changing Q dot name also change P dot name. They share the same object. Are you getting?
Yes, please.
Okay, so one object, multiple references. So any change through one reference is reflected everywhere. Okay. Okay. So now let's move to methods and constructors. So in the previous session, we learned how objects store data using variables. So now we move one step further. How do we make objects do something with that data? So this is where methods comes in. So methods define the behavior of an object, what actions it can perform. So at the same time, we also need a way to automatically set up objects when they are created. So we don't want to manually assign values every time. So this is exactly what constructors are used for. So they initialize objects automatically when we create them. So in the previous example, if we take this example, so here we are manually writing student1 dot name equal to comments, then student1 dot course. So we are manually writing it. So we don't want to manually assign values every time. So in that case, we can use constructors. So they initialize objects automatically when we create them. So in this session, we will learn two key ideas: how to add behavior using methods and how to initialize objects automatically using constructors. So let's begin. Okay. So when you were doing C++, have you ever copied and pasted the same code multiple times in a program?
Yes, please.
Okay. Okay. So imagine you need to display a welcome message for 100 users. Okay. So instead of writing the same code 100 times, we create a method and call it whenever needed. So this saves time and makes the program easier to manage. Okay, so what is a method? A method is a self-contained block of code that performs a specific task. So think of it as a mini program inside your main program. A real life example is think of a coffee machine. Okay, so you press the button, the machine performs a series of steps, and finally it gives you coffee. Yes. So similarly, a method performs a set of instructions and may return a result. So let me give you an example. Let me write it here. So let me write public, okay? Then I'll write void. Sorry, this is void. And then I'm writing the method name as greet. Okay. So it's a public method. You can access it from anywhere. Then inside this method, I'm trying to print a message, welcome to Java programming. So how to print a message in Java? You write system dot out dot println. So I'm not writing in detail. It is system dot out dot println. Don't write it in the exam as s dot o dot p. I'm just writing it here because it's difficult me to write. It's okay. So I'm writing welcome to Java. It's a string. So I'm writing it inside the double quote. And then I'm closing this method. So this method's job is only one thing: display a welcome message. So this method is not returning anything. So I'm making it as void. Okay. So next step is the syntax. So now let's see the syntax. So first will be access specifier. So I'm not mentioning it here because access specifiers are optional. Okay, so let's start with the return type. So in this example, I'm taking it as void. So the return type tells us what value the method sends back after completing its work. For example, it's int, double, string, or boolean, or void. So in this example, it is void. Okay, so if I want to return an integer, so I'll show you another example. So I'm starting with the return type, okay? So I'm writing int. My method name is add. Add. Then I will write return return 10 plus 20. And then I'm closing the method. So this method returns an integer. 10 plus 20 is 30. So that's why I'm reusing my return type as integer. Okay, so that is return type. And next is method name. So method name identifies the method. So it should describe what the method does. For example, calculate salary. Then display student info or find maximum. So good names make programs easier to understand. So don't just use ABC or XYZ. So you should use good names, meaningful names. And after the method name, you can see here arguments or parameters. See, parameters. So parameters are inputs provided to a method. So they are like raw materials required to perform a task. For example, you are making a tea. Okay, so making tea requires you need water, you need tea powder, then you need sugar. So these are inputs. So similarly in programming. Okay, so let me give you another example. So in programming, we have inputs. Okay, so let me create another method. I'm using the same method add, but instead of 10 and 20, I'm taking it as inputs. So I have int a, comma, int b. So I have two inputs, a and b. And inside this method, I'll write return a plus b. So before I was giving 10 plus 20, so the value was fixed. Even if I execute the program 100 times, I'll get the output as 30. But here I'm taking that as input from the user. So if user is giving 30 and 40, so 30 will go to A and 40 will go to B. And return 30 plus 40, the method will return 70. It's an integer. So parameters are inputs provided to a method. Suppose if you wanted to calculate area of a rectangle. Okay, so you are calculating an area of a rectangle and the method name is uh, calculate area. So can you tell me what will be the parameters?
Um, the parameters will be passed to A and B.
Yeah, what will be that A and B? What is that? You're calculating area of a rectangle. So what will be this A and B?
Um, the length and the width.
Yes, the length and the width. So you will write L times B or L times W, area of a rectangle. Yes. And same way, if you
Sorry,
want,
yeah, sorry, can you come again?
see, if you are calculating something
Yeah,
and you wanted, instead of giving the values directly, I mean, how I was giving the 10 and 20,
yeah,
so instead of that, I wanted to provide that value as input to a method.
okay,
Okay, so here I will write, maybe I'll use float, calculate area. Then I will give float L, comma, float B. Okay. And
okay,
inside the method, I will give the formula return L times B. Are you getting?
yeah,
So that method is calculating the area of a rectangle. So instead of fixed value, I'm taking it as inputs.
okay,
See, imagine a machine where um, you are making a tea and everything is inside with sugar. It comes with sugar. Okay. It always comes with sugar and you don't need sugar. Okay, so you are making a choice whether you want or you want a tea or a coffee or with water or with milk. So you are deciding it. So that is parameters. So if there is no parameter means everything is ready made and whatever you are getting it, you have to drink it. Even if you make it 100 times, you will get the same thing. If you execute 10 plus 20, 100 times, you will get the same output 30. Are you getting the difference with parameter and without parameter?
yes.
I think that is not clear. That yes is has some
Okay,
any.
so yeah, I have so the parameters. Are you um inputting the parameters inside the code or at runtime?
Yeah, this, we are just defining the method. Now this A and B, we will take it from the user.
Okay, yeah.
Okay, so here I'm not writing A equal to 20 or B equal to 50. The user will give it, and that will go to this A and this B. So that is the main part that we will do it in the main method.
Okay.
So this is how parameters look. So parameters are inputs provided to a method. They are like raw materials required to perform a task.
Yes. Okay.
Okay. And next we have, see here we have body, method body. So method body contains the actual instructions that perform the task. Means your formula. Just now we did area of a rectangle. Okay. So you have defined the area, calculate area, and you are giving a formula, float area equal to L times B. And you are writing return area. So the result is you are returning it. Instead of printing it, your function is returning a float value. So everything inside, this brackets, this curly bracket is called the method body. Okay, so now let's see the benefits of method. Why we are using methods in programming. The first one is reusability. Write once, use many times. So without method, you need to write system.out.println welcome. You're writing it 10 times or 100 times. Means you are repeating system.out.println. But with method, you just have to mention the name of that method. Welcome or greet. Our example was, I explained a greet. So you just have to write the method name. So less code, same result. And the second point is modularity. Methods divide a large program into smaller, manageable pieces. So instead of writing everything in main, we can create separate methods for login. The login code, we can make it and we can group it into a method called login. And the registration code, you can group it and make it as a method and give the name as register. So each method handles one task. Okay, so an example is take our university. So our university has different departments. We have admission department, accounts department, examination department. Okay, so each department has a specific responsibility. So methods work the same way. And the third one, we have readability. Okay, so you are writing a program where you are writing, you are calculating total marks and you are calculating the percentage. So you are writing int total marks equal to, you are adding all your semester marks and you are storing it in the variable total marks. Or should I write it here? I think that will be better. Yes. So, yes. So here I'm declaring a variable int total. Okay. equal to, you are adding your first subject, subject 1, then second subject, then third subject, and fourth and fifth. Okay. So you can write it S1 plus S2 plus S3 plus S2, S4 plus S5. Okay, and then you are calculating the percentage. So float percentage equal to total divided by 5. So instead of writing this inside the main, I'm grouping this code and I'm making it inside a method, calculate average or calculate percentage. So which one is easier to understand? This one, or if we grouping it into a method and we name it as calculate percentage. So which one is more readable? I mean, understandable? The second one, right? Because by seeing the name, you will understand, yeah, this is a method that is calculating the percentage. The method name clearly tells us what is happening. So methods makes program easier to read and maintain. Okay, so what is a method? Yes, anyone? What is a method?
It defines the behavior of an object.
Yes, okay. So method is a reusable block of code that performs a specific task. You make it simple.
Okay.
Okay, so a method is a collection of uh, code that performs a specific task. So again, it's a simple definition of a method. So every method consists of a return type, a method name, parameters, and a body. See the syntax. Yes. So methods helps us avoid repetition, organize programs into smaller modules, and improve readability, making our code easier to develop and maintain. So what is the purpose of a return type? Yes, anyone? What is the purpose of return keyword, return type? Sorry, not return keyword, return type.
Is it to return the value from a method?
Yes, it specifies a value returned by the type of value returned by that method. And then which keyword is used when nothing is returned?
Madam, please come again.
Void.
Which keyword is used when nothing is returned?
Void.
Yes. Okay, so what are parameters?
Inputs from users.
Yes, inputs to a method. And then, yeah, and the benefits of methods, advantages. That is reusability, modularity, readability. Okay. So any question?
No, please.
Okay. Okay. Just okay. So let me explain this example of a method. So we have time. So just I'll stop it after this. Okay. So in mathematics, have you seen numbers like 5 plus 2i or 3 plus 4i? Yes. Have oh oh yes. Yeah, in mathematics, have you seen numbers like 5 plus 2i? Have you seen?
Yes, please.
Yes. So these are called complex numbers. So they contain two parts, a real part and an imaginary part. So if I take an example 5 plus 2i, 5 will be the real part and 2i will be the imaginary part. Okay, so now we will see how methods helps us manage and display such values in Java. So the first step is understand the class. So here I have a class complex. See, I'm using the name similar to our program. So you can use any name, but always use a meaningful name. Don't use ABC and XYZ. Okay, so class complex, then you are going to declare your variables. So you are going to print complex number. So it has two parts. So there will be two variables. The first variable will store the real part and the second variable will store the imaginary part. So I'm declaring it as double. You want, you can declare it as integer or float. Okay. And then I'm going to create methods for these variables. The first one is void assign real. I'm assigning the real value. So again, I'm taking a parameter that is double R. Because why I'm using double here? Because I have declared the real as double. So you should use the same type here in as parameter. Okay. R. And inside the method, I'm writing real equal to R. And same way, I'm creating another method for imaginary where I'm initializing I to image variable. Again, this is also double because I have declared my main variables are double. So I have to use the same for the parameter. And then I'm creating another method. Now I have assigned these values. So next step is printing this output. So I'll use, again, it's printing. There is no calculation here. I'm using void show complex, means show output, show complex number. So system.out.println, I'm just printing complex number, real plus imaginary part. Okay, so if I'm giving 5 and 2, then I'll get the output as 5 plus I 2 because I am giving it first. I'm closing this method and I'm closing the class. And next, I'm creating another class where I will have my main method. So public static void main. So inside this main method, I will create my object. I will create my object complex R1 equal to new complex. So R1 is my object. So by using this R1, I'm going to call these three methods. So R1 dot assign real. So it has a parameter and you need to input the value. So here I'm directly giving the value 5 and 2. There is another way if you want to take it from the user, then you can declare two variables and you can take it as input, like enter two values or enter the complex number. You give a message and you store it in two variables. So instead of 5 and 2, you will give that variable names. So here you are directly giving it. I will explain you how to do that, but just understand it, how to invoke or how to call a method. So R1 dot assign real. So real has an input. So that value you have to give. And same way, assign imaginary. Again, it has an input. So you have to give the value. And after giving these two, you have to invoke the output method to print the output. That is R1 dot show complex. Show complex doesn't have any parameters, so no need to pass anything here. So when you execute this program, you will get this output. Complex number is 5.0 plus I 2.0. Why it is giving 0.0? Because you have declared it as double. So that's why it is showing the decimal. Showing it as a decimal value. Okay. So this example shows how methods work with objects. So the assign real and assign imaginary methods store values in the object, while show complex display the result. So method helps us organize code, improve readability, and allow us to reuse functionality across multiple objects. Yes. Okay. Yes. So are you understanding? Are you understanding my class? Yes.
Madam,
Yes.
please, can you go over this example again?
Okay. So here we are going to print the complex number. So complex number has real and imaginary part. So you have to declare two variables. You can use int, float, double. You can use any data types. Don't use a string and character. They are only for the alphabets or characters. Okay, so double. I'm using double real and double imaginary. I'm declaring it. So these two variables store double value. So after declaring it, I'm defining two methods for initialization. So void, I'm performing only initialization, no calculation. So you can make that method as void. Method name is assigned real. You have, instead of giving directly in the method like r equal to 5 or r equal to 10, I'm making a parameter. So that is double r. Why it is double? Because I have declared my main variable real as double. So I have to use the same data type here and then open the brackets, then write real equal to r. Okay. And then close it. And same way, you have to define the imaginary part. So you are writing imaginary equal to I. So this is just initialization. And the next step is displaying the output, show complex number. So to print output on the screen, you will use system.out.println. Then I'm writing complex numbers in double quotes. So it will print as it is in the output screen. And then I'm printing the variable real plus I. So again, plus I, I'm writing it inside the double quotes. So it will print as it is. And then imaginary part. Okay. So after defining your class, the next step is you should have, you must create the object of that class. So again, you will have another class where you will have your main method. Okay. So here I'm writing complex R1 equal to new complex. I'm creating the object of that class. R1 is the object. Complex is my class name. And R1 dot assign real. I have to call it. See, these all classes outside the main. So if you are not calling the methods, the main doesn't know that there are some methods outside the class. So main is where execution begins. Main is the entry point where execution begins. So if you are not calling this method inside the main, then you will not see any output on the screen. You will get a blank screen with no output. You will execute the program, but you will get a blank screen. So whatever you have defined it outside the main, you have to call it. So R1 dot assign real. Assign real is a method, but we need to give some input. That is, I'm giving it as 5. Okay. And then R1 dot assign image. Again, I'm giving some value 2 and R1 dot show complex. I'm displaying the output. Okay. So when the compiler executes, when you execute this application, the compiler starts from here inside the main. It doesn't start with the class, then it doesn't go like this line by line. It directly check where is the main method. The compiler checks where is the main method and it will start executing from there. So first it will start creating the object, that is R1. Then it will execute the next line, that is R1 dot assign real 5. Then 5 will go to R. Yes. Any question?
Yeah, please, madam.
Yeah.
Our time is up.
Okay. Oh, sorry. Okay,
And
I'll
I have a question as well.
Yes.
Please, in programming Java,
Yes.
which of the IDEs recommended?
You can install Eclipse or Visual or MS Code or then we have NetBeans. I have already mentioned it in the course outline. Don't worry, I'll share everything with you.
No,
Yeah. So which one you prefer? Maybe which one you want to use? Is it Visual Studio Code?
how about IntelliJ? Is IntelliJ okay?
Okay, IntelliJ. Okay. Then fine. We can install it.
Okay.
Okay, IntelliJ. Okay, fine. So we'll install it and we'll do all the practicals in that.
Okay.
Okay. So I'll explain you this again in the next class and I'll share all the notes.
Okay.
Okay. Okay. So
Thank you.
thank you. Bye. We'll see you in the next class.
See you too.
Okay.
Comment them? Could you do it? Bye bye.
Stephen, is the next teacher coming?
Charlie, me first
Stephen,
Africa say be automated.
no go.
AI. I don't know. I don't know say it be India or Chinese. Benin.
Be like it be India, Charlie. I know they
Is
hear
it
anything.
videos?
Oh, sorry,
Oh my God, man. We the virus. Hello, hi, bye, bye. Hello, videos. You know easy. But these people, if they teach face to face, you will understand power.
Yeah. Then be good, Ralph.
But this one, be video. But Sefa be foolish well. Sefa they can't ask questions. Sefa to the talk like that, give the woman.
She they talk too slow, like she be slow. She they talk like it be too slow.
But
Charlie,
Sefa
if she talk fast, you know we understand. So
we no go fit understand because you know this. No right. What you're doing is not right.
huh?
It's not right. What you're doing is not right.
Then they record you. You did it.
Hey,
So they record
obvious,
you. You did it.
obvious they use my account a fool. Hey, son a fool.
Charlie, the Java there, it go long.
It be Java we dey do or C++.
If you Java,
But they hear C++. Oh, Iba count constants.
yeah. So now she did try explain. She say what we do for C++ is basically the same thing we would do for here. But yes, we say the syntaxes way will be different.
Okay. Not the Vadam. One set pad where. Abi you go use the plus. You go use the plus. I go use the plus.
Charlie, George.
Yeah, move player. Oh. What are they do, sir? That be a move player. Move player the plus.